So let's try a more complex example with tan. I even considered changing the textbook's example to add a vertical shift, but actually I think if I show you the horizontal shift, you'll get the idea. The vertical shift is the same, you just have to then move it up or down. And if that means you draw it 2 or 3 times, then so be it. So let's have a go. This one, matching the example in the textbook, I've written it slightly differently to remind you about the factorising. But we're only doing it between 0 and pi, and the reason is it's going to be a little complex for us to draw, so this is just a simpler initial place to start. First, what's the vertical dilation? Again, I can't talk about the amplitude because it doesn't have that kind of amplitude, but I can talk about dilation. There's no vertical dilation. The number in front of here is 1. So the vertical dilation is 1. It's not inverted, anything fancy like that. It does have a period. Now I'm actually going to factorise this first. Did I leave myself enough room? Let's have a go. Tan of, this is going to be a bit tricky. It's 2 something. Well, if I take out the factor of 2, I'm dividing by 2. So I'm going to get x minus pi on 3. So my period, well, the period of a tan graph is normally pi. So here I'm dividing the pi, the normal period, by this number 2. So it's pi on 2. If you prefer, that's a horizontal dilation of a half. I'm shrinking it a half horizontally. What about the vertical? No, sorry, there's a horizontal shift, then the vertical shift. Horizontal shift, there is one. It's this number here, pi on 3, not this. Factorise it first. But which direction is it? Well, remember, if I'm adding a shift here, I'm moving it left. So I'm subtracting, so I'm moving it to the right. And the vertical shift, there isn't one. I'm not adding some number on the end. Okay, let's set up some axes and then have a go at drawing it. Alrighty. X and f of x. Now I'm going up to pi, so let me draw that in. Here's a hint. I've got thirds and I've got halves, so I'm going to have quarters. So I'm going to be combining thirds and quarters later, so let's divide it into twelfths. There's pi and there's pi on 2. Let me mark my pi on 4 as well and my 3 pi on 4. But I'm actually going to want to come back also with thirds. I've got a shift of pi on 3. So let me mark that in now. I'm actually going to want to come back later and put in some twelfths as well. That's 2 pi on 3. All right. Let me draw the standard tan graph first. I'm going to do that in a nice light colour so that it won't overpower the image, but I can see what I need to do to shift it. So I'm going to draw it with the correct period, but ignoring the horizontal shift first. So the period is pi on 2. Normally the period would be pi. So I'd be coming up at 0, going to an asymptote at pi on 2, coming back up from the bottom at pi on 2, to go through pi and back up again. So at period repeats at pi. Here I'm repeating at pi on 2. So I need to come up here to an asymptote at pi on 4, then come back up at the bottom, come back through pi on 2, up to an asymptote here, come back up here and finish there. So let me draw that in, going to the asymptote here, going up to there, coming up from the bottom, going across to 3 pi on 4, and then coming up from the bottom again and going across to pi. So there's my normal unshifted graph. But I need to shift it by pi on 3 to the right. Well, my asymptote was at pi on 4. Where's my asymptote going to go for the new graph? It's going to be pi on 4 plus pi on 3. Now, given that the purpose of this whole exercise is to be able to do this without technology, let's make sure we can add pi on 4 and pi on 3 without a calculator. Pi on 4 plus pi on 3. I'm going to need them both to be twelfths, as I tried to foreshadow earlier. That's 3 pi on 12 plus 4 pi on 12, which means I've got 7 pi on 12. So my asymptote that was here, let me get my pink pen, my asymptote was here, it's now going to be at 7 pi on 12. Where was 7 pi on 12? It's just past the halfway. That is 7 pi on 12. That's where my first asymptote is going. All right, where's the next one? Period's pi on 2. The next asymptote is going to be pi on 2 later, which is here. But that's after my final limit of my domain. However, there is another asymptote on this graph. Can you see where it will be? It's going to be pi on 2 to the left of that. I've got another asymptote. Now pi on 2 is 6 centimetres, so I'm going back here for another one, which is pi on 12. And that's where my previous asymptote was. That was a bit tricky, wasn't it? Thinking our way through that. Okay, so let me draw the real graph. Oh, just before I do, there's one more thing I need to work out. It was crossing at 0, so it's now going to cross at pi on 3, here. Where's the next crossing? It's at pi on 3 plus pi on 2. Again, we could do some maths or we could measure. What did I say pi on 2 was? Pi on 2 is 6 centimetres. So if I go here and go 6, this is where my next crossing is in my final graph. What's this value? That's a bit tricky, isn't it? Let me go back to 12. I did this at 12 centimetres for a reason. That's 10 on 12 or 5 on 6. That's 5 pi on 6. Now I think I'm ready to draw my graph. I'll just draw this section first, coming up from the asymptote, going through here and going up to my pink marked asymptote. Coming up from the bottom asymptote, going through 5 pi on 6, and my next asymptote would be here, right? Just past pi. So I'm heading towards there, and then I'm just going to, I'm trying to match this curve and just stop, because that's as far as I can go. It wasn't really quite neat, but it'll do. All right, there's one more bit missing. This bit of this graph that I couldn't draw here, I actually have to draw over here. So it's coming down from that asymptote until we get to 0. So my black line is tan of 2x minus 2 pi on 3. And there in black is the graph I want. If you do draw your graph multiple times, I mean, if I had had a vertical shift as well, I might have drawn it once in blue, once in something else, and then finally again in black. Do mark at least the final. It may even be worth marking in blue what this one is. This one was tan of 2x without that horizontal shift. Just makes clear to the person marking it, who at the end of next year might be an external exam, external marker, it makes it clear that you did understand exactly what you were doing.